The title of the first section of notes is Determine, Vertical, Asymptotes, and holes. When we get to graphing on the next section, vertical asymptotes will be dashed lines that the graph cannot cross, and holes will be empty spots in the graph. The two definitions: vertical asymptotes, the definition and how to find a vertical asymptote is where the function is undefined. If you remember, undefined would be where the denominator is equal to 0. And the second definition would be for a hole in the graph. A hole is if the factor cancels out. In order for a factor to cancel out, it'd have to have the same factor in the numerator and denominator. Our first question, f of x is equal to 2 over x minus 3. To find a vertical asymptote where the function is undefined, that's going to be the same as the denominator equaling to 0. So x minus 3 equals 0. If you solve that by adding 3 to both sides, x would equal 3. So for this question, our vertical asymptote would be x equals 3. If there was a hole, the factor would cancel out. For example, if you have x minus 3 in the denominator, you'd have to also have x minus 3 in the numerator. So for this question, there's no holes. There's only a vertical asymptote, which is at x equals 3. For the second question, we have g of x equals 2 for the numerator over x squared plus 2x minus 8. Again, to find the vertical asymptote, we want to find where the denominator is equal to 0. In this case, we can factor the denominator. This would factor to x plus 4 and x minus 2. And again, to solve this, each of these could be equal to 0. So x plus 4 could equal 0. And also x minus 2 could equal 0. If you solve each of these, you'd have x equals negative 4 and x equals positive 2. Both of these are vertical asymptotes, so we'd have two vertical asymptotes for this problem. So if you wrote the answer, you would have vertical, x equals negative 4, and x equals positive 2. And again, if there were holes in this graph, the factors we have, x plus 4 and x minus 2, we'd have to have the exact same factor in the numerator. So no holes for this graph, but there are two vertical asymptotes. And last question for this section, h of x equals x minus 5 in the numerator and x squared minus 4x minus 5 in the denominator. Again, the first step, set the denominator equal to 0. In this case, again, we can factor the denominator. this would factor to x minus 5 and x plus 1. And again, each of these you can set equal to 0 to find the vertical asymptotes. So x equals 5 and x equals negative 1. So again, there are two answers, x equals 5, x equals negative 1. Those would be vertical asymptotes. So vertical x equals 5 and x equals negative 1. For the holes on this graph, again, the definition of a hole is if a factor cancels out. If we go back to our original question, we have x minus 5 in the numerator, x minus 5 in the denominator. So these two factors would cancel. And what that means is where it's equal to 0, x equals 5 would be our hole. So if the factor cancels out, set that equal to 0, and that's a hole. Since we have the same answer for the vertical asymptote, what we can do is cancel that one out. X equals 5 is no longer a vertical asymptote, it is now a hole. So our two answers, vertical x equals negative 1 and a hole x equals 5. Our first question for horizontal asymptotes is f of x equals 2x to the third plus 2 over x squared plus 4x. Again, for horizontal asymptotes, you compare the degree or the highest exponent of the numerator and denominator. In this case, the numerator has a higher degree than the denominator. So looking at the definitions of horizontal, a higher degree in the numerator means there is no horizontal. Second question, g of x equals x to the third minus 2 over x to the fifth. And again, you look at the degree or highest exponent. In this case, the numerator has a lower degree than the denominator. And looking at the definition, a lower degree in the denominator means the horizontal is y equals 0. Again, when we graph, the asymptote is a line that does not cross the graph, so we have a line at y equals 0 that the graph does not cross. And the last question for horizontal asymptotes is h of x equals 2x squared plus 6x minus 5 over 3x squared minus 4x plus 2. And again, for horizontal asymptotes, you look at the highest exponent or degree. In this case, they're both the same. The definition is a fraction for the leading coefficients. The leading coefficients are the number in front of the highest exponent. In this case, it's 2 over 3. So our horizontal would be y equals 2 over 3, or 2/3. The last section of notes today is titled Graphing. Rational functions. To graph rational functions, we'll use vertical asymptotes, holes, and horizontal asymptotes. The first question is f of x equals 2x over x plus 1. First thing we'll do on this is find the vertical asymptotes, the holes, and also horizontal asymptotes. Once we find those three, then we can graph the function. Vertical asymptotes, again you set the denominator equal to 0, x plus 1 equals 0. In this case, x would equal negative 1. The holes on the graph, again if a factor cancels out, we have x plus 1, but there's no x plus 1, so there is no holes. The horizontal asymptotes, you look at the degree of the numerator and denominator. Both have the same degree or same exponent, which means you'll make a fraction from the coefficients 2 over 1 or just 2. And the horizontal is y equals 2. Using these, we can start to graph. Draw a xy axis. A vertical asymptote at x equals negative 1. A vertical asymptote will be a straight dashed line that goes through x equals negative 1, and when we graph, the line of the graph cannot go through the vertical asymptote. There are no holes, so we don't have to worry about the holes. Horizontal, the same thing as the vertical, except it's horizontal at y equals 2. And you have a dashed line going across, crossing at y equals 2. Again, the graph cannot cross the horizontal asymptote. With the vertical and horizontal asymptotes, we have 4 sections of the graph. Rational functions on the left side of the graph will either use the top or bottom section. Basically, you'll have a curve either on top of the graph or you'll have a curve on the bottom of the graph. The same thing for the right section, because it cannot cross the vertical asymptote. You'll either have a curve on top of the graph or a curve on bottom of the graph. To decide whether it's top or bottom, you can use a t-table. And on the to decide which points to use in the t-table, we want to pick one point to the left of the vertical asymptote and one point to the right. This vertical asymptote is at x equals negative 1, so the next point over would be negative 2. Negative 2 we can plug back into our original equation. Negative 2 times 2 would be negative 4. And negative 2 plus 1 would be negative 1. Negative 4 over negative 1, the y value would be positive 4. So if we graph this point, negative 2, positive 4, this point tells us the graph is on top of the horizontal asymptote and not on the bottom. Once you know it's on top, you'll basically curve the graph. It goes parallel to the vertical asymptote. It cannot cross the vertical asymptote. Same thing when it gets towards the horizontal asymptote, it has to curve and go parallel to the horizontal asymptote. That's the left side of the graph. And then we'll have the same thing on the right side of the graph. The curve will either be on top or it will be on the bottom, and you have to pick another point for the t-table. X equals negative 1. We can pick a point to the right, which would be 0. Plug 0 into the original equation. 2 times 0 would be 0. 0 plus 1 would be 1. 0 over 1 would be 0. So our point is 0, 0. And again, the graph is either on top or bottom of the horizontal asymptote. This point tells us it's on bottom. If you draw a curve that goes parallel to the vertical asymptote, continues through the point, and again goes parallel to the horizontal asymptotes, the graph can never cross a asymptote. Next question that we'll do for graphing rational expressions. is g of x equals 6 over x squared plus x minus 6. And again, the first step when you graph a rational expression is you want to find the vertical asymptotes, the holes, and horizontal asymptotes. First step again, the denominator you set equal to 0. This one we can factor. This question factors to x plus 3 and x minus 2. If you set that equal to 0, you'll have x equals negative 3 and x equals positive 2. These will both be our vertical asymptotes. X equals negative 3 and x equals 2. The holes again, the factors, you have to have the same factor in the numerator and denominator, which we don't, so there are no holes. Horizontal asymptotes, you look at the degree or highest exponent. The numerator does not have an exponent, but it's kind of like x to the 0 power, so the numerator has a less degree. A lower degree means y is equal to 0. Once you have your asymptotes, you can draw the xy axis. Vertical, x equals negative 3. Again, would be a dashed line at x equals negative 3 that the graph cannot cross. Also, x equals 2 will be another vertical line that the graph cannot cross. There are no holes, and the horizontal asymptote is at y equals 0, which is the x-axis. So we'll have a dashed line going across the x-axis that the graph cannot cross. On this one, we have 6 sections. We have 2 sections on the left, 2 sections in the middle, and 2 sections on the right. Same idea as the last problem. The graph can either be on top or bottom of each section. You'll either have a curve on top or a curve on bottom. The middle sections will be like parabolas. You'll either have a parabola on top or a parabola on the bottom, and the right side will either curve on top or curve on bottom. To decide top or bottom, again, you can do a t-table. We'll pick one point to the left of the asymptotes, one point that's in the middle, and one point that's on the right. This is at negative 3, so we can pick the next point over, which is negative 4. Going back to the original question, you have 6 on top. If you plug a negative 4 in, negative 4 squared would be 16, plus x, which would be minus 4, and minus 6. 16 minus 4 would be 12, 12 minus 6 would be 6, and 6 over 6 would be 1. Graphing that point, negative 4, positive 1, tells you again the graph is on top of this first section. Curve the graph by the asymptotes, and it goes parallel by the horizontal and vertical asymptotes. Next point we'll pick is in the middle of the graph. Anything between negative 3 and positive 2, nice easy point would be 0. We'll still have 6 on top of the fraction. 0 squared would be 0, plus 0 is 0, and minus 6. 6 divided by negative 6 would be negative 1. So the point in the middle graph is 0 and negative 1. Again, we have a horizontal asymptote at y equals 0, so the graph cannot cross here. We know the graph's on the bottom with their point, so you'll basically have a parabola that goes through that point and goes parallel by the vertical asymptotes and turns around before the horizontal asymptote. Last part of this question is the right side of the graph. We need to figure out if it's on top or bottom. This point's at 2, so your next point over, you can pick x equals 3. 6 again, just a number on top of the fraction. 3 squared would be 9, plus 3, and minus 6. 9 plus 3 is 12, minus 6 would also be 6. So 6 over 6 would be 1. So our point 3,1 tells us the graph is on top of this section. So again, you curve the graph between the asymptotes and you have your answer. Last problem for this section. The equation is h of x equals x squared minus 25 over x minus 5. And again, the first steps on these, you want to find the vertical asymptotes, find the holes, and find the horizontal asymptotes. Vertical, again, you set the denominator equal to 0. So x would equal 5. Holes, again, are when a factor cancels out. On the denominator, we have x minus 5. The numerator doesn't have x minus 5, but you can actually factor this. Difference of squares to x plus 5 and x minus 5. If you factor it, you'll have x minus 5 in the denominator, x minus 5 in the numerator, so these factors would cancel, setting that same factor equal to 0, and that's where a whole x equal 5. Like before, if you have the same vertical and whole, you can cross off the vertical, since you'll be graphing the same number. Since there's only one vertical and we crossed it off, there's actually no vertical asymptotes for this graph. There's a hole, and for the horizontal, you look at the degree of the original problem, x squared over x. The numerator has a higher degree. Looking back at the definition, if the numerator is higher, then there is no horizontal. So for this graph, we have no vertical, no horizontal, and we only have a hole. If you rewrite the question, h of x, the x minus 5's canceled out. All we have left is x plus 5. Graphing this one would just be a linear line, mx plus b, where m is equal to 1, b is equal to 5, and you can draw your graph from there. Keep in mind there's no vertical, no horizontal for this graph, so we don't have any dashed lines. If we start at b equals 5, or the y-intercept, b equals 5, the slope is 1, so we'll go up one spot, over one spot. The difference on this graph between a normal mx plus b linear line and this graph is there is a hole at x equals 5. What that means is we have to go over to x equals 5. If we start to draw the line, figure out where the line is going to be at x equals 5, we'll put an open spot or an open circle for a hole. The line goes to that hole, the line is going to be missing this point, and then the line will continue on like normal. And that would be the answer to the question. So our original equation, x squared minus 25 over x minus 5, is a straight line. With one exception, there's a hole at x equals 5.